Good day. Today we will be looking at June 2022, paper 2, question 10. Okay. It says, in the diagram, triangle ABC and triangle DEF are drawn such that A is equal to D, B is equal to E, and C is equal to F. Use the diagram in the answer book to prove the theorem which states that if two triangles are equiangular, then the corresponding sides are in proportion. So we're wanting to prove congruency here. In order for us to prove congruency, we're going to have to construct some lines. So the first thing that we're going to do is we're going to construct a line. You can label it whatever you want to label it. Let's say LM. So we're going to construct LM here, ensuring that AL, so let's make this L and M, AL is equal to DE and AM is equal to DF. Okay, but you must construct that on your paper and you must write that you're constructing. So we're constructing, we're going to draw LM on triangle ABC such that, so you must ensure that it's the same distance as well when you're drawing it, such that LM, such that AL is equal to DE and AM is equal to DF. Okay. Sorry about the noise. Now let's start our proof. So in triangle AMN and triangle DEF, the first thing is what we just constructed. So AL is equal to DE, my construction. AM is equal to DF, my construction. And then the last thing is an angle. So we're going to say angle A is equal to angle D. And that was given. Now we can prove, we can say therefore, triangle AMN is congruent to triangle DEF, and the reason is side, angle, side. Now that we know that, we can say that LM is parallel to BC because of our proof. LM is parallel to BC, and therefore we can say, and the reason would be corresponding angles are equal as well. Now we can say therefore AB over what we just found, which was LM is equal to AC over AM, and the reason is proportion theorem. State your parallel lines, LM parallel to BC, and now we can conclude and say therefore AB is parallel to DE, which is AB over DE is equal to AC over DF. And my reason is for that is the AM is equal to DF and AL is equal to DF and AM is equal to DF. AL is equal to D and AM is equal to DF, which were my lines that I constructed. Let's go through this proof again. Okay, so we constructed LM on this line such that AL was equal to DE and AM was equal to DF. And then we wanted to prove congruency. So we prove congruency by saying that AL is equal to DE, AM is equal to DF, and angle A is equal to angle D. Then we concluded by saying that triangle, sorry, made a mistake here, ALM is equal to triangle DEF because we're just working with those top triangles, okay? And my reason was side angle side. Therefore, LM is parallel to BC because they are congruent. And we know that this ALM, that angle M there is equal to angle F. And angle F is also equal to angle C. Therefore, these lines are corresponding. So let's write that out. I missed that step. So I said angle AML is equal to angle F from what we just proved. Okay, so I said this angle is equal to this angle, and this angle is equal to this angle because we proved congruency. But F is also equal to C, therefore C and M are also equal. So it's also equal to angle C. Therefore, we can say that LM is parallel to BC because the corresponding angles are equal. And if those are corresponding, that means these lines are parallel. That means that AB over AL is equal to AC over AM. Proportion theorem, which is what we proved. Because we proved that, we can conclude that AB is also over DE and AC is also over DF. Okay. Proofs are a lot, but you just have to learn it step by step. Okay, last question for this section. It says in the diagram, O is the center of the circle passing through A, B, C, D. So O is my center of the circle. There's O. Okay. EC is a tangent. So here it's EC. Diameter DB is produced to meet EC at E. F is a point on EC such that BF is perpendicular to EC, so we've got this right angle here. Radius CO is produced by sec AD, so we've got equal lines here. Let's go to what we need to calculate. If we want to analyze this first, I would draw my radii. That's a radii, that's a radii, that's a radii. Okay, these two are equal. Lots of theorems that I see here, lots of things that we can draw, but let's go and see what they actually require us to look at. So prove with reasons that FB is parallel to CG. So taking a look at what we have here, let me erase what we drew. So we know this is 90 here. They want us to prove that FB is parallel to CG. That is 90. I need to find this to be 90 and then I could prove corresponding angles. And this is 90 degrees because it is the FCO is 90 degrees because I've got a tangent coming to a radius. This is my tangent, here's my radius. Remember I said earlier this is a radius. Therefore this is 90 degrees. And F1 is equal to C1 and 2, which therefore makes it corresponding. Okay, so let's write out what we wrote. I wrote FCO is equal to 90 degrees. My reason is tangent perpendicular to radius. F1 is equal to 90 degrees. That's given. Therefore, FCO is equal to angle F1, which is equal to 90 degrees, and then we can conclude that FB is parallel to CG, corresponding angles. Okay, the next question, 10.2.1 B. Says, wants you to prove that triangle FCB is similar to triangle CDB. Okay, let's take a look at those triangles first. So we're looking at, let's keep our parallel lines though. This is parallel to this. We're looking at if CB, and we are looking at CDB. So we know that this F2 is 90. I also know that BCD is 90 because of angles in a semicircle. D2 is going to be equal to C1 because of tan chord theorem. This is the tangent and here is my triangle. And then the last one is always sum of angles of the triangle. So let's start with by saying in triangle FCB and triangle CDB, the first thing that we said is BCD is equal to 90 degrees, this angle here, because of angles in a semicircle. I also know that angle F2 is 90 degrees. I can say sum of angles on a straight line. Therefore, BCD is equal to angle F2 because they're both equal to 90. The next one is C1 is equal to angle D2, and my reason is tan chord theorem. C1 and D2. And then the last one is B2 is equal to B3, and your last reason is always sum of angles of a triangle. Therefore, we can conclude that triangle FCB is similar to triangle CDB because we proved angle, angle, angle. Okay. Take a look at the next one. 10.2.2 says give a reason why G1 is equal to 90 degrees. Only one mark. G1 is equal to 90. Here we've got the line coming from the center to G1. And what reason or theorem or law do you know that would prove that to us? It's going to be line from center to the midpoint of a chord. Okay, the next one says prove with reasons. 10.2.3 that CD squared is equal to CG plus DB. Okay, so that's a lot. They want us to prove that CD squared is equal to CG plus GB. So looking at this on where we have and what we have, we need to use those triangles. Okay, we need to create a similar triangle to create a relationship to find CD squared. So the triangles that we should work with that is going to give us those values is going to be triangle GCD and triangle CDB. Okay. GCD and CDB. So the first thing that we can see is that G2 is equal to 90, but BCD in the yellow triangle is also equal to 90, which we calculated earlier. C3 in the orange triangle is equal to D2 because of angles opposite equal sides. Okay. Remember, this is a radii and this is a radii, so C3 and D2 will be equal. So angle C3 is equal to angle D2. And the last one, we need one more. Oh, and the last one is always sum of angles of a triangle. So GDC is equal to angle B3. This was angles opposite equal sides, and the last reason is sum of angles of a triangle. Okay, now that we have proved that, we can say that triangle, always state what triangles you're working with as well. In triangle GCD and triangle CDB. So now I'm going to say triangle GCD is similar to triangle CDB. Now that I've proved that, I can create the ratio that's going to help me solve what they asked me to solve. And the reason that I did these triangles is because I looked for the triangles that have these values in them. So now I can say CD over DB is equal to CG over CD, because I'm wanting to create the same value, the same ratio. Now I can cross multiply. CD squared is equal to CG times DB. And I have what they asked me to calculate. The last one says hence. And when they say hence, they want you to use what you calculated above to find the next answer. So it says hence prove that DB is equal to CG plus FB. So let's use what we just calculated to help us solve that question. So we know that those triangles are equal, are parallel. But we also have we also have another triangle set that's similar, which was triangle FCB was similar to triangle CDB. Because we see now that we have an FB. Where's that FB going to come from? It has to come from here. So let's create a ratio now that has FB in it. So it's going to be BC over DB. Your values have to be in relation. So do you see here I've got BC, DB. They're next to one another. You can't just be taking random ratios. Now I'm taking FB because I want FB. But if I'm taking FB on this side, I have to take CB on the other side. But CB is also BC because I need it to be the same to cross multiply. So I'm going to have BC squared is DB times FB. Now I have the FB. I need to correlate it to this. So I'm going to combine the two. Okay? So I'm going to have CD squared plus BC squared is equal to CG times by DB plus DB times by FB. Now what we're going to do is we're going to take out a common factor or see what we have here. So on this side I have a common factor of DB. I'm going to be left with CG plus FB. And you can see now that I'm getting somewhere to what I have here. With the CD squared plus BC, if you take a look here, CD squared and BC squared are part of the triangle. So both of them together, adding them, is going to give me DB squared because of Pythagoras. So both of them squared together gives me DB squared. And now I have what I need. Because I can take cross multiply, I'll be left with 1 DB CG plus FB. And that's the final answer. let's quickly take a look at mark allocation. These ones were very high in marks. It was 5 marks. The first one, statement, and this was the reason for the statement. Any other statement for creating the sum and your answer, 5 marks. The 10.2.3, identifying your triangles that we were going to use, was 1 mark. And I missed that out, so make sure that you don't forget to identify what triangles you are using. Statement and a reason, and another statement, 5 marks in total. So as you can see from the mark allocations, as long as you are giving correct statements and reasonings, you should get correct answers even if you aren't getting to the final answer. G1 is equal to 90 is 1 mark. Then the previous question was B, and this was also 5 marks. (10.2.1) B, 5 marks. So I'm not going to go through it, but statement and reasons for 5 marks give you 5 marks. Then A, statement and a reason, statement and your answer, 3 marks. And your proof was 6 marks. 6 marks for statement and reasons and 1 mark for construction. So 1 for construction and 5 for statements and reasons. Thank you.